So how small a p-value do you need to reject the null hypothesis? Okay, now that's subjective. It's a human decision like most things in statistics. It's something that we agree upon how we're going to do it. And there's no universal level that you reject at. We call it the significance level, and you have to tell what it is when you do a problem or be given that in a problem in class. If you look back at the notes for the central limit theorem section where we talked about the sampling distribution of x bar, at the very end of that I did this problem where there was a company that was servicing air conditioners, and we looked at the probability that the average repair time was less than 1.1, and we got the probability was 18%. That was technically a p-value if you look at it in the right way. So I think in that one it was 80%. I'm thinking of the calculus problem earlier where it was 18%. And you could think of that example too. But there was an 80% chance that they would be able to service on time, 20% chance that they couldn't. And I mentioned, is that good enough? You have to decide for yourself. So how much evidence is good enough evidence? So we have to define the significance level, that if your p-value is below a certain level, you're going to reject, and if it's above that level, you're going to fail to reject. So we call that the significance level. It's customary to use the Greek letter alpha for that. And there's no universal rule, but it's most common to see alpha as 0.05, which means we're going to reject if there's less than a 5% chance that what we found in our sample would have happened, but it did happen. So we're like 95% confident we've surpassed the 5% threshold on our p-value we would reject. Now, if you're doing a medical experiment, the stakes are high, you might want to have a much lower value there that you're going to reject by your significance level. Okay. But the process is you have some level, like say 5%, and if your p-value is less than that, you're going to reject the null hypothesis and conclude in context that your alternative hypothesis is the case. And if your p-value is larger than your cutoff level, you're going to fail to reject, in which case you just can't conclude anything. You just failed to reject. You didn't get strong enough evidence. It's either you reject the null hypothesis or you don't. Okay? You don't prove the null hypothesis, so never say that. That's just not the way it works conceptually. So again, the idea, if you look back to my calculus example, our probability was about 1%. So if the real class average was 70, there was only a 1% chance we would have gotten a certain type of sample, but we did. So something happened that shouldn't have happened if the mean was a 70, unless it was just by 1%. There's always the chance we're making a mistake, and we're going to talk about that in another section. We actually have names for those types of mistakes. But when you reject, you're basing it on probability. You want to be pretty confident, but you're never 100% confident unless you look at the entire population. So we usually go with about 5% or maybe 1% or 10%, depending on how high the stakes are. But if your p-value is small enough, less than 5% or 1% or whatever your cutoff level is, you reject the null hypothesis. If it's bigger, you fail to reject. And they're really picky on this in statistics. Once you pick that value, that's it. If your p-value is, or your significance level is 5%, and you find a p-value of like 5.1%, you would fail to reject. So we have here a 4-step process for doing a test of significance. And this is true for any significance test, not just the z-test for the mean that we're going to look at. But you want to state your practical question. What are you trying to answer with your statistics test? Identify the parameter. Is it a mean? Is it a proportion? Is it the difference between two means? And then use that to state your null hypothesis and your alternative hypothesis, and then pick the appropriate test. By the time we get to the end of the class, we're going to have a lot of these to pick from. So the first one we're going to look at, we're going to use the z-test when we're doing a single mean and we know sigma. When we do a single mean and we don't know sigma, we use something called a t-test. When we're comparing more than two means, we use something called an ANOVA. If we're comparing two means, there's a two-sample t-test. There's lots of tests that we have, so it depends on the situation. Okay? And then you carry out the work. You check your conditions. There's always certain conditions, such as simple random samples, independent samples, things like that. Calculate your test statistic, find your p-value. Okay? So like with the z-test, you would calculate a z-score and then use that to find a p-value. Now, we have built-in calculator routines that if you give it all the right information, it usually outputs both of those things at one time. But you need, in theory, you need the test statistic to go to the density curve to find the probability, which is the p-value. And then in the end, you make your conclusion, which should be written up in plain English to tell the practical answer to the question. You're going to come up with reject or fail to reject the null hypothesis, but you need to tell what does that actually mean in the context of the problem. So in this section, we're going to look at the z-test. I think I'm going to go ahead and stop this video at this point and then pick up the next one here with the z-test.